How's it going, chat? Um, all right, let's take a look at where I'm at with this project. Can I just let's read about this. Creates a new empty dictionary from a sequence given. Takes a Python dictionary, empties the dictionary, takes the length. Huh. Okay. I'm not really sure if that's the best way to do that. I'm just I'm let's see what other projects are doing because I'm curious how like I'm not really sure what the ergonomic way to do this is. Let's see. Hmm. Hmm. What about other fields, such as head atoms or headers? Yeah, I thought it might be that. Okay, so what if we try that? Okay. So if this is the case, then this changes quite a bit. residues, bonds, chains. Okay. Okay. So I think then what that looks like for me is a little different because yeah. So then what if we did this and said, so right now we say that it's a collection of records, which is true. But it's actually a pi result of Python records, which are slightly different. But like, is it really? I don't think it is. I think a Python record could be potentially a pub. So like rather than it being a record, oh, which is going to screw up this whole thing. Um, what if we played around with the idea of like pub atoms? Yeah, that's not exactly right either. Because this would look a little different because so we'll do like this. We don't really have this yet. I don't. We'll just say like that. I guess we could just say like continue. That's not really what I want. Uh, yeah, let's try that. Okay. We don't really want it to be that. So let's. Okay, so realistically, this makes a lot more sense to me that we would have a structure of atoms. But the problem is that it's not. Because that's not exactly accurate, really. Because the record is just a single line, but like we are building a structure that holds multiple records. Um, so I wonder if we. This is maybe not the right thing. Maybe this part is okay, but how we access them is going to be different. Yeah. Okay, so let's get rid of this. Okay. So I think probably what this might look like instead is we have a pub struct, um, let's say like topology, which contains a vector of atoms. And then I think we can do pio3 get set on that. And then that just, boom, now we have getter and setter on that. Let's move this to here. Is this the right one? No. Okay, so that looks a little different then, because then it's going to be nope. This one. Yeah, we want this. D. Okay, so we'd put it here like that. We get a pi class. That's the self here. So then we get that. I don't think this is. What are you doing? Great question. We are building a parser for protein databank files, which is basically a it's basically a way that we store protein data, and we've written a preliminary parser for most of the parts in Rust, and now we're going to add. We're going to do some bindings for Python, so you should be able to do something like this. You can call Python code that actually uses the Rust, my Rust bindings on the back end. So you should get a substantial speed up to do a lot of your Python or your like computation. We're using a cool project called PyOxide. How long do you need to complete it? Um, I don't have a time limit on it. I've been working on. So this is the second iteration of this. The first one was written in Zig, and that one was how long was I working on that one? That one I've been working on since September. This is the rewrite. I've been working on it for like 3 weeks. It was pretty easy to port. Um, but yeah, I don't really have a time limit on it. I'm just kind of hacking on it when I have time. Hey, thanks. You too. Thanks for stopping by. But yeah, feel free to ask any questions you have. We're like I said, we're going to be working on this, so you know, just take a look. Let me know if you have any questions. All right, so we have the set of atoms. We're going to set the topology here. So I think that should be fine. But then how will that look here? Okay, so let's try this instead. I think this might be a better py function, pub func parse topology or did I import topology? Yeah, I thought not. Use py. Actually, it's here, so we can say like topology here, and this will return a py results to a topology. And what we'll do is let mute topology equals a, yep, there we go. And then we can just say top. Or okay. Top. I guess technically we do like, right? Oh yeah. Okay, top. Okay, so then how that looks from a parallel perspective is we'll do this here. So we need to use add the use here. So that's collecting the records. But I guess what we could do here instead is this. Hey, thanks for the follow. I appreciate it. So I think probably what we'll do is we'll parse the records out. We need lines, so lines, which is a string. Did I screw something up there? Oh, yep. File, and then we say let lines equals yeah, that. Oh. Okay. So, all right, so we get the lines. I don't want that there. I want that like here. Yeah, no worries. I usually stream around this time Tuesdays and Thursdays, but I'll have more soon. Thanks for stopping by. I appreciate it. All right. Ooh, interesting. How are we doing that before? Yeah. Yeah, so that's a good call. So we should probably do Python atom record. Because this is technically also fair. So we can say like het atom. And then that handles that case. And then we also need to do, since we're doing this in parallel, we will need to do this part. But it's a little easier to work. All right, so what does this mean here? Oh yeah, we don't need that part. Just totally remove that. Okay, so that does basically the modifications there. Make sure that everything's, the serial numbers are all lined up. So we can do this. Oh, and it crashed on me. Top.atoms record. Okay, cool. So now we should be able to do source matcher and develop. Actually, I source lib.rs. So I think what we would need to do is add this. So m.add function. Let's build topology. Cool. We want topology. Ooh, het atom. Yep, there we go. Like, I wonder why those lines didn't line up. You know the idea? Topology. Cool. Build topology. Done. Awesome. So then from the Python perspective, just comment this out for right now. We set up the we set up the topology by doing topology. It's not going to be that. It's going to be knuckles build topology from the PDB, which is the PDB in this case is the raw string, so it'd be like all of your bytes, and we're going to feed that into here like that. And then what we do is we can say for atom in topology. Let's see if we can do that. We might be able to. And I think we saw before that that's kind of how OpenMM works with it. Yeah, atom.id, atom.name. So like, let's see if we can do that. Let's see if we can do a little atom, atom.name, position, or we can just do this atom.position. See if it crashes. Matrin, develop, Python, test up. Is not iterable. I guess that's right, right? Because technically it's nvim test.py. So this I think would technically be like .atoms, right? Yeah, okay. So we're taking the topology, getting the atoms, printing the atom. Okay, so I don't have position set up yet. Oh, yeah, that's not even a thing. Atom.id, that's the one I want. Let's see if that one works. Okay, so I don't have that set up yet either. Okay. Let's see. Which ones do I have set up? iCode, chain ID, alt location, name, serial. Oh, serial. Okay, so then in that case, it'd be serial. There you go. Done. So let's try doing the same thing in OpenMM, and we'll kind of drag race them against each other. Okay. Um, um, import from simtk.openmm.app. I'll import that. That's what we want. Then what we can do is we can do OpenMM. So ideally, we want to benchmark both of these. So we'll do like this. Here we'll do this. I guess we won't do the print. We'll just build the topologies and see what we get. We'll just comment that out for now. We'll do ×1. I know this is likely Python. That's fine for right now. And then we'll do another loop for I in range. I wonder if there's a way. I feel like I did this once before. PDB bench. Yes, I did do this. Yeah, because you can open the file ahead of time. Like you can just open it once. So we say like, yeah. So we can do. No, we don't want to do that. Get rid of that. Go. ×1. Okay, and then what we'll do is we can say file equals PDB file, and we just pass it file. Okay, so this is a pretty decently sized file, so we should see how fast this thing can go. All right, so that does the parsing there. We do it. We'll do it 10 times on each. Then what we'll do is we can do average one is ×1 ×1 yank paste. Like that, and then we'll say total 1, average 1 ×1, average 1, and then we'll just do cool. All right, cool. So this is really just, it's not doing any of the printing, but like the whole goal is like how fast can it get it into the structure, which I think this can do. And it should give us a pretty decent idea. Uh, okay. Did I screw some up here? I really don't want to use Conda for this. I have a virtual environment. Please let me just use it. Anaconda. Okay, very cool. That's fine. Uh, that's fine. Okay. Let's see. How do we? Let's see. Install open mm pip. I don't. Oh, that's because like OpenMM version 0.2. Ugh. How did I do it here? Did I just use a Nix flake? I probably did. Yeah, I did. Okay, so I wonder if we can just add it here. There has to be a better way to install this. From openmm.app import star. All right, so we need a little way to install this. I don't want to install it though. Let's try it with the flake. Mvm. Uh, here. Um, I think we can do this. Oh yeah, because it's using the hmm. Let's try this. Python 311 dot. Yeah, I'm getting the build right on this is going to be kind of tricky. I'm not really sure. Uh, Python. I don't think this is going to work. Man, do I love Knicks. Let's go, baby. There we go. Ah, that's awesome. Okay, cool. So I think we should be able to run Python test.py. Oh, Python test.py. Oh, matcher source. Oh, deactivate maybe. Loading it. That's what I. Okay, that's fine. Well, that's fine. That'll be annoying though. Okay. Test.py. All right. So there's. I thought I would be able to do that. So let's do. I think it's just openmm.app. Is there? Did they change that? Uh, let's see. OpenMM PDB file. We can pull that over here. Loads a PDB file or string. The name of the file. You can pass an open file object. List index out of range. It shouldn't matter, but what just happened there? All right, let's try just passing the path directly. I know that's not like see that's not a great test though. Because then it's going to read in the file, I think, every time. Yep. We need to iron out these tests so that the file read doesn't happen like in the there. Because like, yeah. Interesting though that they kind of changed their thing to do like a get topology thing. Number of frames. Hmm. So it's a class. Yeah. So we're able to parse the topology a lot faster. Um, Granted, we're only doing the topology. We're not doing like the rest of this. So we're not doing like the number of frames, which is an interesting notion. And maybe it's something we need to look at. But like this, we get this like really great speed up from just parallelizing under the hood, and then providing API functionality for you to grab the data you want. Right. So like if you look, like on average, these are taking like about 8.7 seconds to parse. That's ridiculous. That's crazy. Now, granted, we do need to do some optimizations on the test because like I'm really not. Oh, so what if we do file two? I wonder if I can. I wonder if I pass the raw PDB if that'll work. What in the? Oh, it did it fail? Yeah, I don't think it liked that because it assumed that was file name. Oops. Okay, so let's just try that one more time. I'm just curious. With open. Hey, thanks for the follow. I appreciate it. Cargo, Python test.py. Let's see if this one works. I saw a book called Write a Compiler with Go. Do you think it's a good starting point? It seems interesting. Yeah, that is a very good book. I would recommend starting with. So that book builds off of his first book, which is Writing an Interpreter in Go, and I would definitely recommend taking a look at Writing an Interpreter in Go. Because it kind of gets the mental model there, and then the compiler kind of gets to a point where you have all of the rest of the pieces. But yeah, I would definitely take a look at it. It's a good book. My other favorite Go book I have is this one's decent. It's network programming with Go. It's a pretty good read as well. But yeah, I would definitely take a look at the compiler book and the interpreter book. Both are very good, and will teach you a lot about computer science. Yeah, I've thought about trying to maybe do part of the interpreter book or the compiler book in Rust. I've heard it's kind of difficult, but I'm interested. Looking to search for a job when I finish university. Yep, I get it. I hear you. You think a programming language is good portfolio stuff? Um, yes and no. Um, are you doing a degree in like computer science or computer engineering or like some sort of computing field? Yes. Okay. Yeah. I so let me preface this by like my kind of path in computing is kind of less than normal. My background was in computer engineering, but like I did IT, and then I kind of ended up back in programming. Um, I think that um, like just it's good to have on the portfolio. My thing is like I think the portfolio is good. The big advantage of like the things you want in your portfolio are things that you can explain and you're passionate about. And I think that'll get you a long way. Like I think just like having stuff that you can sit and talk about and like why you made the choices you did is really important. I think that using the compiler book is a good um, and stuff like that is a good starting point. But I think that the benefit from it comes from how you can put like optimizations in and like what changes you made that are a little different from the book, and like being able to explain those things is really powerful. So I hope that answers your question, but it basically the whole thing is like for me, like I find that like when I have a portfolio and people ask me about it in a job interview, for example, it is so much easier for me to sit in that interview and talk to an interviewer when I can explain the decisions I made, right? And I can talk about, oh, well, I decided to, use this language over this one because of whatever reason, or maybe you were just interested in it or whatever. But having like a good background of like what you've worked on is kind of like is I think is more important. So whatever you work on, go for it. But yeah, I think because I think that it's a good benchmark of like talking about engineering, right? Like if you're an engineer and you want to explain, a lot of the job, right, is just like making like doing some work, making a choice, and kind of explaining why you made the choice you did, right? And being able to like kind of walk through that. So I think that if you have a portfolio that like you just know deeply and are able to talk about is good. Now, there is something to be said about like if you're looking at a job and you want to be like a Go dev, having a Go project in your portfolio probably a good thing, right? Or if you wanted to be like a Rust dev, having a couple Rust projects in your portfolio, not a bad thing either. Um, Now, that's not to say that like for everything you need to have that, because I think that there's a lot of um, you can kind of explain analogs between languages sometimes, but I think that having like some part of your portfolio be, you know, what what you're interested in, but then also like what you're working on, like what you're excited about is also important. Um, so like my portfolio has see if this goes. Yep. So like my portfolio has like a couple of my projects. Like it doesn't have this one on here yet. But like these are a lot of the projects I've worked on. Some of these are ones that like I maintain. Some of these are ones that I built at work. Some of them are things that I have built in the past. But like some of these are not even necessarily difficult projects. But I can explain to you everything about them, right? So the commit engine is like a really easy one, right? So this one, all it kind of does is walk through and allows you to build conventional commits. But the point of it is that it's not a necessarily like very difficult project, but I can sit here and I can walk through and talk you through all of that, right? And I think that gets you a long way. Um, but I think the advantage of doing something like building a compiler or something like a interpreter, right, is more. Yeah, yeah, exactly, right? And so that's my thing. Like this shows a couple things, right? It shows that I know Git one, but it also shows that like I know kind of some best practices with Git, right? Which that's also nice, like because then it kind of shows both sides of it. Um, and that's the thing, right? Like so personally, I think that like for me, a lot of the stuff that I've built is stuff that I use. So Git's is one. Like I've worked on Garlic for work. Um, LogSocket is something that I've used and like I've written tests for. NVim Last Place started as it's archived now, but it started as a project that I used because I wanted to rewrite it in Lua. All of that code was stuff that I had written for because I was like just interested in it and I kind of wanted to see and learn that thing. So the thing that I will say is like working on the like just kind of going through and trying to find like like I know X skill and then if you have something that can kind of back that it helps. Um, then again, I don't know. I'm not really an expert. I've never had to hire someone. I can't really speak to that. But for me personally, like I think that having some projects that you can talk through is helpful. Because also I think for me personally, it helps me kind of to walk through and explain like what um uh it helps for me to be able to like be less nervous in an interview because like I know these projects, right? They're my like I know them inside and out. So I can easily walk through them and say, "Oh, look, like I was the one who was kind of responsible for um making that happen." Yeah, so I my thing is I think that finding the thing that like maps tools to that to the whole um like mapping tools is kind of a good place to start. Think you want to be a backend developer? I'm gonna say I personally am gonna say good choice, but I think that all developers have like they're very powerful in what they can do. I personally like am a backend developer by trade, bioinformatics and a bit of deep learning. That sets you up in a great spot. It puts you in a great spot. And we really need to fix the chat on the screen here. I think we could probably just do this. That'd be better. Um, yeah, if you know a bit of deep learning, that puts you in a pretty decent spot. And also bioinformatics is good too. I think the other cool thing about like bioinformatics and deep learning is like when you have those skills, it definitely puts you in a it definitely puts you in a cool spot because you have like some data analytics. Yeah, a lot of text processing. You get the data analytics kind of piece. It is weird. Yeah, no, it 100% is. So like, right for this, um, like we can look at the structure here. This is all text processing, right? We're like extracting these from. This is actually done, so we can remove that. But this is just extracting stuff from a line and a string, right? But like the reality is there's a lot of that. Like there's a lot of things that just need text that needs to be processed and put into a in a manner that's more that you need to work with. That makes it easier. Yeah, I think that the thing is just build projects that you're kind of interested in, and I think that's the best project. I don't think that like having a project that is a specific thing is necessarily like the you know the best spot. And my other caveat to that too is also I'm not going to say like go commit to an open source project just to commit to an open source project because I think that commit if you find something that you want to change. But do recruiters consider age? I don't know. I don't know. I don't think so. I think that like they don't they don't really care honestly. Like I don't know. I think that really what it comes down to is like what you know. And like I doubt that age is gonna like come up because I mean it's not even generally it's not on the application, you know. So I don't think it really matters that much. We need to figure out where I'm gonna put chat because like it does not work on these backgrounds here. Yeah. So for context, like I have a degree in computer engineering, and so I did a lot of like embedded system stuff. Oh no, no worries. It's exactly what that this is for. Like it's more than okay. Um, my background is was in computer engineering. I did a lot of like embedded system stuff. Um, it's taken me to some interesting places. Like I've written some embedded system stuff since then. And it was a good skill for me to have, but I by no means think that that makes me like a great developer or anything like that. But the one thing I will say is like my background was, like I said, I got my degree, I did IT for a little bit, worked that, just got really into automating my IT work, and then decided to move on. Where I'm not super into, but the only way to get money. Yeah, I unfortunately, so I'm a bit off time with the development world. Yeah, right. And if you have a bioinformatics background and you're doing computer stuff, that gives you like a really great, you know, it gives you a good jumping off point, right? Because you can say, um, like it gives you a good jumping off point for like working with like what projects you want to work on, because you have a background in saying like, oh, like I know bioinformatics, but like I also am learning all this programming stuff. How can I do bioinformatics stuff in programming? And it doesn't have to, and like I said, it doesn't have to be a crazy project. It can just be like, I'm going to build one, I want to take a workflow that I've used in the past and I want to automate it and like demonstrate that and do it. And I think that that'll get you a long way, because I think it shows that you like know how to write stuff and you know how to like make decisions and you know optimize for performance in places. And when someone asks you like, oh, like why did you do it this way, you can explain why you did it that way. I think that gets you really far. Yeah, but please, anyone in the chat, feel free to ask about anything. It doesn't have to be related to the code. It can definitely be related to um, stuff with programming. If you have any questions about like any specific um, stuff, that's a good thing. Now, I will say, if you were talking about backend developers, I think that book I showed earlier, the writing like web architecture in Go, is a good one. Network programming in Go. It helped me get like become a better backend dev, because like I said, my background is in embedded systems, so I like I took one class in networking, okay, in college. That's all I did, and then I kind of like ended up in a backend role, but like that's like what my backend was in. And then just kind of interfacing with that from an IT perspective. Um, Network programming with Go was a good primer of like just understanding like how to build an API and like how to like put all of that out there, and it touches on things like gRPC, which is like really nice to work with. So it has some good resources of just stuff and helps you kind of like work through the networking model. No, 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 no. So Git is like, so here's my thing with Git. Git is a hard one to do when it's just you, right? Because like I think that so much of the power of Git is the working in teams. So like learning Git is hard to do, but like it's easy to like kind of learn the basics of it and apply that in your local thing, in your local projects. So like when you're working on a project, like check it into Git. Like even if you don't have to, check it in, and get used to that like version controlled kind of those kinds of changes. And I think that gets you a long way. I think network programming with Go does a good job of talking about building like web systems if you're looking from a backend perspective. Yeah, and that's a hard part too, right? So a lot of times, like when you're working in a team, that's where the merge conflicts kind of start popping up and things like that, where like Git can kind of be really powerful, and also like it's a way to help you kind of find bugs and things like that as well. And like I said, like it's taken me, I've been using Git for, I don't know, probably 10 years, but like most of that time was by myself. And then like as I've gotten further in my career, it's been a lot more of it's been a bigger change, right? So for me, that means that like, oh, we've been, like I've learned how to use it for working with my coworkers to try and like make sure that we're all in sync. but also like using it for bug tracking stuff and things like that. Now the other thing is like so I use it in an IT context, and that was a completely different way to use Git. Like I would not use that how I do Git for development because for that it was like DevOps kind of work. So that was a different kind of work. Um, yeah, I would just say just start looking at it, start using it, and see how far you get. There's a lot of great tutorials on how to use it out there. And just get used to the flow of it. Like just get I think the hardest part with Git with like new developers and like people like learning how to use Git, a lot of it is just like getting used to the fact that like I finished a thing. Let's check that thing in the Git. And then that way we have a record of the fact that I made this one change on something. Now it doesn't need to be like I changed the line, let's make a commit, but it can definitely be like, hey, I added a feature, right? Let's make a commit. Um, and like writing good commit messages is like making it useful because like you have to remember that like Git is a tool to show history, right? And that's not its only reason, but like its big purpose is to show history, and so using it as a tool to demonstrate that is very powerful because it gives you the opportunity to say, oh yeah, like this is all of the changes I did, and then it allows you to like go back in time and go, okay, cool, like where I made this change one time, how do I now bring that up to speed? All right. So I think we're in a better spot now. Um, I need to move this out here. I think that's more accurate. Let's see. These 10-second times are going to kill me. For sure, yeah. Always feel free to ask. I am more than happy to answer any questions you have and go through that. Um, yeah, I want to do a stream on like using Git at some point because I think that there's a lot of ways to use it, and I think that it's really powerful. All right, come on, let's go. Boom, there we go. That's ridiculous. All right, so my goal is I'm curious how they get the number of frames. Right? Get number of frames from a pile. So let's open up the source for OpenMM source. Yeah. Simulate PDB structure, PDB reporter, holds a parse protein databank file. Is that the one I want? What's the difference between like PDB structure? Is it just internal? I think that's how it's holding it. Okay, cool. That makes sense. Uh, PDBX file, PDBX parser, simulate charm, PDB reporter, PDB structure. Okay. Yeah. See, that's the thing. So when I'm doing like this PDB model, like when I'm doing the parsing, it's not really like one-to-one because it's doing all this other stuff. Build a topology. If you take an atom by number, we iterate through the chains, we add to the chain, get the residues, and the name. How nested this is kind of, it's hard to trace sometimes. For model in self yield. What is yield? Sends value back to the caller but retains enough state to enable the function to resume where it left off. When the function resumes, it continues execution immediately when the last yield was run. Oh, so every time it calls it, it calls. That's interesting. Okay. Model. Add model. Oh, that's a good point. I didn't even think about resetting the atom numbers, but we'd have to. Because like every model technically has its own atom numbers. Oh wait, that should matter because we're not doing that. We're parsing the lines one at a time. Okay, so do we have support? I already have the model, right? Records model. Yeah. Okay, so chain dot finalize. Ugh. All right, yeah, I got to do a little bit more work on the actual processing of this. Okay, but on the right side, we already have the parser like ready to go. So my goal is I want to kind of emulate the OpenMM structure and see how fast we can get from just speeding it up with parallel processing. And then boom, we're done. But unfortunately, chat, I have to get going. So let's find someone to raid today. And feel free to drop in and say hi. Let's do Spiro. He's writing Zig, so we gotta support our Zig homies out there. Thanks for everyone for stopping by. I appreciate it. And as always, have a great rest of your day. I will be back on Thursday to do more of this. So very cool. See you guys later. Take it easy.